Hello, Excel geometry. Okay, what we're doing today is we're actually going to begin section 10.7, all right? We have 2 days of 10.7 notes, so this is just day 1. So guys, what we're going to take a look at today is we're going to kind of extend chapter 10 just slightly and get into the equations of circles. So right now, right here, if you printed out the sheet, this is a standard form for the equation of a circle. If you did not print out the sheet, no worries, just copy your notes on a sheet of paper. So for our equation of a circle, your standard equation of a circle is right here. X minus h squared is equivalent to, x minus h, the quantity of x minus h squared plus the quantity of y minus k squared equals r squared. So what does everything represent? Now, if you take a look at this, h and k, that minus h and k, that represents the center of my circle. So that represents the coordinate points for the center of your circle. R is the radius of my circle. All right. Now, how is that found? It's actually found using the Pythagorean theorem. Because remember, or actually we can say even distance formula, because we've talked about how we can derive the distance formula from the Pythagorean theorem. We can also derive the equation of the circle from that distance formula, which was derived from that Pythagorean theorem. If you think of a circle, all right, guys, so I'm going to draw a circle. If we think of a circle, we talk about, so I'm going to make my little circle. If I think of my circle, I have a center and I have a radius. And we talked about how the definition of a circle is all points equidistant from a given point. And that equidistant was represented by the radius. Well, if you had the center as that point HK, and xy would represent every point on the circle, and they always remain our variables because there's infinite many points on that circle, and x and y can constantly vary. If I was to find the distance of r, I would say x minus h, the difference of the h's, plus the difference of the y values, y minus k squared. If I'm plugging in the distance formula, I would find the square root of that, and that would be equivalent to r, which is the distance of the radius. Now to find that circle formula, all they did was square both sides. So that if you take a look at that, if I square both sides, here the square root and squaring something are inverse functions, so you're just left with x minus h squared plus y minus k squared equals r squared. And that's where the equation, the standard equation of a circle came from. It was just derived from the distance formula, which has been derived from the Pythagorean theorem. So if you take a look at this, if a circle has a center, so if we take a look at this, center 4, 7, all right, guys, center 4, 7, and has a radius of 5. Write the equation of the circle. What we're going to do is we're going to plug in the 4 for h, the 7 for k, and the 5 for r. So your equation will be x minus 4, the quantity of x minus 4 squared, plus the quantity of y minus 7 squared would be equivalent to 5 squared. And we can simplify that to x minus 4 squared plus y minus 7 squared equals 25. Now be careful, that's the answer. Never distribute an exponent. We cannot distribute exponents. This just means an exponent represents that you're taking this whole binomial and multiplying it by itself. So be careful there. That would be your final equation for the equation of the circle. Now, if you're going to graph it, what you're going to do is start by graphing the center. Now, your center is 4, 7. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. This is my center, 4, 7. Now, right here it says find 4 crosshair pins. What does that mean? What that means is if I know the radius is 5, there's 4 easy ways to draw a radius from that point. Meaning I'm going to go right 5, up 5, left 5, and down 5. Those would be my 4 crosshair pins. So I look at them, and they're going to make, the reason we call it that, it makes a cross. So from here, 1, 2, 3, 4, 5. And I would go up 5, 1, 2, 3, 4, 5. I'd go left 5, 1, 2, 3, 4, 5. And you'd go down 5, 1, 2, 3, 4, 5. Now, if I even took a look at my graph, I can even just do it here. If I take a look at that C, that center C, I can say I'm going up 5 for one point, I'm going right 5 for 1 point, so that would be 9, 7. I'm going left 5, 4 minus 5 would be negative 1, 7. I'm going up 5, I would add 5 to 7, so that would be 4, 12. I'm going down 5, I would subtract 5 from that 7, and that would be 4, 2. Those would be my 4 crosshair pins. And guys, listen, I know it's difficult to draw a circle, and even me, I don't have a circle that's going to fit that one perfectly, so just do the best you can of connecting those 4 crosshair pins. And then you can label your radius. So you can draw a radius anywhere. So I can take this, I can draw a radius like this and label it 5. So that would be how I would graph that circle. All right? Now, here's another thing. Now they said, given the 3, 4, 5, now this is interesting. Given a 3, 4, 5 Pythagorean triple, add additional lattice points. Now, lattice points are just points that are not going to be on a crosshair. They're going to be additional points on that circle. Now, what they're saying is 3, 4, 5. 5 represents my hypotenuse. Do we all agree? Of that triangle. This is the hypotenuse. So what we're saying is can you construct a 3, 4, 5 triangle in order to make additional points? Now, watch this. Let me actually erase that for a second just to show you how. If you take a look here, if I start at my center, and I can add a bunch of additional points, and this only works when we have a Pythagorean triple, so I want to make a note of that. Watch this. I can form right triangles. So, for example, I'm going to take my green. I can go right 3, up 4, and that should be a point on my circle. Or I can go left 3, up 4, and that should be a point on my circle. The reason why is if I draw the hypotenuse should be 5, which is my radius. So I can do that. I can also go down and in both ways. So that would give me 4 additional points. So what would those 4 points be? It would be from this point, I would go right 3 and up 4. Think about it. If I'm starting at the center, I'm going right 3. I'm adding 3. So if you have your 4, 7, you are going to go right 3. You're going to add 3 and up 4. You're going to add 4. So one of the points would be 7, 11. You're also going to add 3 and go down 4. So the point would be 7. I add 3 to my 4 because I'm moving to the right, so that affects my x. Going down would affects my y. 7 minus 4 would be 3. Those would be 2 points. If I went in the opposite direction, I would be subtracting 3. If I go left, I'm subtracting from my x value. If I subtract 3 from x, I have 1. If I'm going up, again, it would be 1, 11 and 1, 3, because I went up 4, down 4. That gave me 4 lattice points on my circle. Now, this is with center C. They're not the only 4 lattice points. I could also, take a look at this, go right 4 and up 3. Because if I change the orientation of that right triangle, I would still have a radius of 5. So I can go right 1, 2, 3, 4, up 3. And that would give me another one. Same thing as instead of going just up, I can go down. And I can go down. All right, so now I have 4 additional lattice points. And this helps me find some other points on my circle. And remember, this only works if your radius is the hypotenuse of a Pythagorean triple. So now if I take a look at this, or a hypotenuse of a right triangle, but it's easier to identify them when they're a Pythagorean triple. So now I went right 4. If I went right 4, 4 becomes 8, because if I go right, it affects my x value, and I went up 3, right? So 7 plus 3 would be 10. I also went right and down 3. So if I went down 3, 7 minus 3 would be 4. Now if I go in the opposite direction, so I started at 4 and I went left 4. I'm going to be at 0. If I go up 3, again, it's going to be 0, 10. And this, I went left 4. That affects my x. So 4 becomes 4 minus 4 is 0. And I went down 3. 7 minus 3 is 4. So these, here I would have 8 lattice points. And all the lattice points mean is points that are not our crosshairs. They're not going directly up, right, left, up, down. All right? Very good. Now let's take a look. Let's flip it over. All right. Find 2 points corresponding to x equals 6. Same problem though. So we want 2 points that correspond to x equals 6. We did not find them here. They were not one of my lattice points. They were not one of my crosshairs. So how can I approach that? Well, if I want x to be 6, I can go back to my equation and plug 6 in for x. So what I can do is, in this equation, I have x minus 4 squared plus y minus 7 squared equals 25. That's our equation from the first page. Now what I can do now, if I want x to be 6, I'm going to take that value of x, 6, and plug it in for x. So let's take a look what happens. I get 6 minus 4 squared plus y minus 7 squared equals 25. I now have an equation with one variable, so we're just going to solve it algebraically. 6 minus 4 is 2. 2 squared would be 4. And then I have y minus 7 here. Minus 7 squared equals 25. I'm going to bring the 4 over, and I'm getting y minus 7 equals 21. Well, y minus 7 squared equals 21. Then you're going to have to take the square root. So you're actually, and we're going to leave this in radical form, you're going to have y minus 7 equals the square root. But when I take a square root, I have to take a positive and negative. And we are going to do that here. All right, guys, we are going to do that here to check. And then you're going to have to add 7. So you have y equals 7 plus or minus the square root of 221. Now, why is it necessary to have 2 answers here, plus and minus? And they're both correct. Well, because you're going to have 2 points in this case. You're going to have x is 6. It's going to be 6, 7 plus the square root of 21. And the second point will be 6, 7 minus the square root of 21. And if you look, guys, that makes sense. Why does that make sense? Well, if I go to my circle, if I go on the other page and I go to my circle and I count 6, I go from 0, right? I hear 0, 1, 2, 3, 4, 5, 6. I encounter what? Wait. Oh, I went to the wrong spot. I was like, wait a minute, we would have known those points. If I go to 6, 1, 2, 3, 4, 5, 6. If I go to 6, I have this point here and this point here. These 2 points, I have 2 points with an x value of 6. So it makes sense that when I solve it, I get 2 answers. 6, comma 7 plus square root of 21 and 6, comma 7 minus the square root of 21. And I'm completely fine with you leaving it in that form, that radical form. Now, let's think of it. If I get a y, if they say, okay, well, what happens to the point where y equals 8? We're just going to substitute the 8 in for y now. So you have x minus 4 squared plus 8 minus 7 squared equals 25. Now, if I solve this, 8 minus 7 is 1. 1 squared is 1. I'm getting x minus 4 squared plus 1 equals 25. And if we solve it, you get x minus 4 squared equals 24. Take the square root. You have x minus 4. Remember, we're taking the positive and negative square root because there should be 2 points that have a y value of 8. So I'm getting the positive and negative square root of 24. Now I can add 4. But be careful, I can simplify this. 4 is a perfect square factor of 24. So the square root of 4 is 2, and then 4 goes into 24 6 times. So it should be x equals 4 plus 2 root 6. So now this is my answer for x. I have two values of x. And if I put it in coordinate points, I'm going to have 4 plus 2 root 6, 8, and 4 minus 2 root 6, 8. And does that make sense? Well, let's take a look. Let's flip this over and see, do we have 2 points when y is 8? Well, if I go to my graph and I go 1, 2, 3, 4, 5, 6, 7, 8, do I have 2 points? Yes, I have a point here and I have a point over here. So there are 2 points on my circle where y is equivalent to 8. So that makes sense. Now, what value of y corresponds to x equals 12? Well, let's take a look at this. If I put this in, I get 12 minus 4 squared plus y minus 7 squared equals 25. Now look what happens here. 12 minus 4 is 8, so I'm getting 8 squared, which is what? I'm going to just write it out to save myself space. 64 plus y minus 7 squared equals 25. Then I'm getting y minus 7 squared equals, if I subtract this, I'm taking, 64, 25 minus 64. Wait a minute, I'm going to get a negative number here, right? So I'm getting negative 39. That doesn't make sense. Wait a minute, because the reason it doesn't make sense is I'm going to have to take the positive and negative square root of a negative number. Why does this not work? Well, if you go over to your picture and they're saying x equals 12, where's 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, x equals 12 is this vertical line. The reason we don't have a solution is there are no points, this vertical line, x equals 12, does not intersect my circle. Therefore, there will be no y value on the equation of my circle when x equals 12. So the answer there is no solution. All right, guys, so let's take a look at our next problem. It says the endpoints of a diameter circle are negative 3, 5, and 5, 10. Find the center of the circle. Well, think about this, guys. If we're finding the center of the circle, and I have a diameter, the center of the circle will be the midpoint. So let's recall our midpoint formula. All right? Let's recall our midpoint formula. So if I do that, I'm going to add my x's, find the average of my x and the average of my y's. Negative 3 plus 5 would be 2. So I'd have negative 3 plus 5 over 2. And then 5 plus negative 10 over 2. And we would get 1 comma, negative 3 plus 5 is 2, 2 over 2 is 1. 5 plus negative 10 is negative 5 over 2 is negative 5 halves. That would be the center of my circle. All right? The radius, well, if this is the center and I wanted to find the radius, what I would do is find the distance between the center and one of the points. It doesn't matter what point we work with. So you would say the radius is equivalent to the square root of, we'll say 1, it doesn't matter, we'll do 1 minus a negative 3, so it's a plus 3 squared, plus 5, in this case, 5 halves, negative 5 halves, plus, minus 5. Squared. So let's take a look. So your radius would be equivalent to 16 plus, this is negative, in this case, negative 7.5, right? So it would be negative 7.5 squared. Now this is one that I think isn't going to come out super pretty. But let's take a look at what it is. Sorry guys, I just need to grab something. So if we take a look at that, so you did, you have 1 and you have negative 5 halves. So we had 16 squared. Then you had negative 7.5 squared. So you're dealing with this. So you have r equals the square root of what? 7225, correct? Leave it like that, and I'm going to explain why. If you can actually find it, but there's a reason, there's a value to leaving it like that. It is 8.5. It's not even approximate, which is 8.5. So that's our radius, right? So your radius there is 8.5. But what I'm saying is there is a value to leaving it in the square root form, and I want to show you why. Because when I go to the equation of the circle, it's x minus the x value of the center squared plus y minus the y value of the center, which is plus 5/2 squared, would equal the radius squared. Well, think about this, guys. If you do ever leave it in radical form, if you had 72.25 and you squared it, the square root and the square cancel. The reason I emphasize that is because if you round a radius, you won't get the exact equation. But if you input in the square root and that square root and the two cancel out, the square cancel out, you would have the correct equation with no margin of error. All right, guys, so let's take a look at example 3. It's our last example for today. Now, if you take a look at example 3, and I know this is a lot, where's the point of tangency? So a circle has this center and is tangent to the y-axis. So guys, let's take a look at this. If that's the center, I go 1, 2, negative 2, 1, 2, 3, 4, 5, 6, 7. If it has to be tangent to the y-axis, this is my y-axis. That means the radius would have to hit that point of tangency. So the point of tangency would be on the y-axis. So what would my radius have to be here? That radius would have to be 2. So that point of tangency would have to be 0, negative 7, because it's on the y-axis. The radius of the circle would have to be 2, because if it's tangent, that means that line of tangency would only hit the circle at one point. So that radius would have to go from the center to that one point of tangency. Now it says write the equation of the circle in standard form. Well, now that we know the radius is 2, and this is my center, I can do x plus 2, because I'm subtracting a negative 2 squared, plus y plus 7, because I'm subtracting a negative 7, and that makes it both positive, equals the radius squared, which is 4. And if I want to graph it, guys, I'm just going to do the cross pins, because I do not have a Pythagorean triple, so I do not have to worry about lattice points or anything like that. And that would be my circle. All right, guys? All right, we are done for the lesson for today. Your homework is below. If you have any questions, please come see me at office hours. Your homework will not be due tonight. Homework will be due tomorrow at 8 p.m. But really, you don't have to complete it and upload it. It will just be part of a small portfolio or that I'm going to have prior to this quiz. So I'm going to have all the homework due prior to the quiz. If you have any questions, please come visit me during office hours. Talk to you soon.